Okay, section 2.3, second example problem. Woodward has contracted with a rock group U3 to perform at the school. The gym can accommodate at most 1,000 people. The band has guaranteed the ticket receipts would be at least 4,800. The tickets are $4 for students, $6 for non-students. U3 will be paid $250 for each student, $450 for each non-student. And then here comes the question. So the question is, what is the minimum pay for U3 and how many of each ticket must be sold for this? Okay, so we're looking at U3 gets paid a profit based on tickets. What's the minimum that could be? And how many of each ticket? So my variables are going to be the number of each kind of ticket. Okay, so my variable, I've got student ticket and non-student ticket. So I'm going to let S equal the number of students, and N is the number of non-students. So how many of each of those ticket types? I want to minimize, so I'm looking for the minimum profit. Sounds sort of counterintuitive, but the band is trying to decide, do we come or not? What would be the minimum profit that they make or the minimum payday? And so that minimum profit, we're told that they would receive $2.50. So 2.50 times S for every student ticket plus 4.50, 450 for every non-student. Okay, so students, non-students, go to my graph. This is the number of students, and this would be non-students on the vertical axis. So students and non-students, and now I just need to fill in what are my constraints. So if I look at, I've got broad categories of constraints. I have S, and I have N, and then I have some kind of limits. So if I read the problem for what kind of limits that I have, the gym can accommodate at most 1,000 people. So I can have no more than 1,000 people in the gym. How does that relate to S and N? That would be the number of students plus the number of non-students. So the number of student tickets plus the number of non-student tickets, that's 1,000. So this relates to my capacity. The other thing relates to the revenue that I make. So it tells me that I'm guaranteed ticket receipts would be at least 4,800. So we will sell tickets and we will have a revenue of at least 4,800. That revenue is $4 for every student and $6 for every non-student. So that is my revenue. So I'm ready to go now. I've got my constraints and I should be good. So the constraints are obviously S is greater than or equal to 0, N is greater than or equal to 0, and then I've got S plus N. S plus N has to be less than 1,000. And then my other constraint is 4S plus, let me make that a little bit clearer. I'm trying to make my S's not look like my 5s. So 4S plus 6N is greater than or equal to 4,800. And so now it's just a matter of graphing this. So before I graph it, let's go ahead and figure out what points I'm going to need. So for S and N, when S is 0, N is 1,000. When N is 0, S is 1,000. So that's pretty straightforward. And then I'll look at the other line. When S and N, when S is 0, N is going to be 6 times 8 is 48, so 800. And when N is 0, that'd be 4 times, I think, 1,200. So those are the points that I need to graph. So it looks like my S-axis needs to go up to 1200, out to 1200, and N needs to go to 1000. So let's label our axis accordingly, and we should be good to go. So I need to get out to 1200, so I think I'm just going to do it this way. I'm going to say that's 500, that's 1000, and that's 1500. And I'll do the same thing. This is 500, 1000. That should be as far as I need to go. So I've got the point 0, 1000, which is right here, and 1000, 0, which is, that's right there, 1000. So let's connect those two. Okay, you'll notice I've got a less than for this one, a less than equal, so I'm shading below that line, okay? So I know that for this line, I'm shading below, okay? And then if I look at the next line where I have 0, 800, that's right here, and 1200, which is right here. So if I connect those 2 points, and if I look at this one, remember I'm shading above that line. So I need to shade below the blue and above the red. So if I shade in that area, that would be this, below the blue and above the red. So that's my feasible region. So I can tell I'm going to have 3 vertices, okay? So it looks like this one is 600, 400. I can double check that. So I can do that with matrices. I know that SN is going to be equal to inverse matrix of 1, 1, 4, 6 times 1000, 4800. So I can do that real quick on my calculator. So let's go over and do that. So that's menu. I'm going to create a matrix 2 by 2. So I'm going to have, what is it, 1, 1, and then 4, 6, 4, 6. I'm taking the inverse of that. And multiplying that by, and then I've got 1000, 4800. So a new matrix. So 1000, 4800. And that is 600, 400. So that tells me that this point is 600, 400. So now I know all of my vertices. They are a 0, 1000, and it looks like 0, 800, this one, and then 600, 400. So it's now just testing those 3 points. So I've got 0, 1000, 0, 800, and 600, 400. So I just need to test each of those. So I'm going to test the profit. So the profit at 0, 1000, and remember my function was profit equals 2.5 S plus 4.5 N. So that's going to be 2.50 plus 4.5 times 1000. So that is going to be 4,500. And then let's try at 0, 800. That's 2.5 times 0 plus 4.5 times 800. That's 3,200 plus 400. Let's see, 3,600. And then let's try the last point, 600, 400. So that's 2.5 times 600 plus 4.5 times 400. So let's see, that's 1,200 plus 300, so that's 1,500 plus 1,600 plus 200 is 800, 1,800. Add those and I get 3,300. So looking at the minimum payout, that would be 3,300. So the minimum pay is 3,300. So I'll rewrite that, 3,300. And that comes from selling 600 students and 400 non-students, okay? Okay, so that's it. Again, problems can get long. The steps start to get repeatable, but hopefully you're getting more comfort in doing those. So that was the second example problem that we worked in class in section 2.3.